Hello everybody. Today we are going to do just part of chapter 4, which is the factors in food preparation chapter. And we're going to do an activity in class covering the first half of this chapter. So what I'm going to cover today in this lecture is safety concerns that we'll keep in mind throughout all of the labs. And we'll also discuss important key points about temperatures that are important for food preparation. Now, for kitchen safety, this is only going to cover some of it. We'll go over more in reminders throughout each lab. But a couple of things to know up front. Make sure that if you spill anything, that it is cleaned up very quickly. You know, if you spill something on these floors, it can make the floors very, very slick. And it doesn't just mean water, but if you're ever spraying, cooking spray on a pan over the floor, that can make the floor really slick as well. So be very conscious of spills, clean them up immediately so that nobody gets hurt and nobody falls. The other thing, now we don't have any mats or rugs in the lab, but if you were to have a mat or a rug in your own personal kitchen, or if you're working in a restaurant, you want to make sure that your mats and your rugs don't slide when you're standing on top of them. They should have some sort of grip to create friction so that you don't step on them and slip and fall. And it's also a little bit better to have one that's easily cleaned or wiped off, because a lot of times they'll collect bacteria and mold, and that can cause more contamination in your kitchen. With the electrical appliances, if you're not using them, they should always be unplugged. Now that is not just for safety, it can also be for environmental protection of the electricity and not wasting it. But especially if we're cleaning anything with sharp edges, you want to make sure that everything is turned off and unplugged before you use it and before you wash it down, just to make sure that you don't get cut or you don't get electrocuted. Hair restraints, so this is everybody's least favorite part of lab, is you must wear a hairnet. I don't know how many times I have been eating at restaurants or even eating at home, and you're eating and enjoying your food, and all of a sudden there's a big old hair in your food. Nothing's more unappetizing than that. So we will wear hairnets in lab. You'll just learn to love it. Knives. So you'll be cutting a lot in this class. Please be very careful. Do not rush while you're cutting. We try to keep the knives pretty sharp. So, don't just throw them on the counter. Don't leave them close to the edge so that they can fall off. And if you're the person responsible for doing the dishes, make sure that the knife is on the counter and you don't actually put it in the water until you're ready to wash it up. You never want to throw knives in the dishwater until you're absolutely ready, because you could reach in there and cut yourself. There is a little bit, a nice little block in your book that talks about the best kind of knives to have. For example, if you want a really nice quality knife, you want it to where the blade goes all the way from the tip to the handle. And they call that where the tang is all the way in the entire length of the blade, which we're not going to get into a lot in this class. We'll talk a little bit about chopping, but we will not cover too much about the different types of knives. Hot pads, so there's different kinds. You've probably seen the ones that are gloves and they go over your whole hand, and then they have the ones that are just a square that you use to pick up things. Obviously, you want to make sure that those hot pads are in use anytime you pick up anything hot, and you also want to make sure you watch where your hand is positioned on those hot pads. Obviously, you can have a large hand and the hot pad is too small and you can burn yourselves. And handles on pans, make sure that they're not extended over another skillet or stovetop so that they don't get hot from that. It's better if they're kind of off to the side. You don't really ever want your pan handle kind of hanging off the edge of the stove, because it could cause you to walk by and knock it off, or somebody else, like a child if you're cooking around kids, to pull it down on top of them. Now, let's talk a little bit about temperatures, because I think I've mentioned this already when we talked about food safety. We'll talk about the temperatures of what we're going to cook food, but these are also some basic temperature information that we're going to keep in the back of our minds. So freezing, obviously most of you have seen freezing, and that's when you transition from a liquid to a solid. And the freezing point is the temperature at which this will actually happen. this process where it becomes solid, you actually lose some heat from that liquid or that water if it's converted to ice. And when you lose that heat, they call it the heat of solidification, to where you lose some of the heat energy that comes from that. And then when ice is changed maybe back into a liquid, it has to reabsorb some of that heat energy. That's the reason that water is so cold when the ice melts, then again, obviously. Water freezes at 32 degrees Fahrenheit or 0 degrees Celsius, and it depends on what other things are in that liquid as far as how quickly it will freeze. So for example, sugar and salt will adjust how quickly things get to freeze. Sugar depresses the temperature at which it freezes. Freezing point drops about 3.35 degrees Fahrenheit. But if we're talking about salt, it has an even greater drop in the freezing point compared to sugar. So we'll talk about this a little bit when we make ice cream. Ice cream freezes much faster when it has that ice-salt mixture that's around it, because it can drop the temperature so much faster. And we'll talk about how if you add a whole bunch of sugar to that ice cream as you're mixing it, how it can change how quickly it freezes as well. Other temperatures, and we'll talk about what a double boiler is in class, but a lot of times you'll use a double boiler if you're trying to melt something or cook something, but very, very slowly, and you want a nice uniform heat distribution around it so it does not burn at the bottom. And there's 3 different levels that we're going to talk about when you are heating up liquids. So a lukewarm temperature is around 100 degrees Fahrenheit, not too much above what you're going to have, like if you're doing dishes maybe, or you're taking a bath. It's going to be a little bit above body temperature. It's not going to feel like it burns, but you'll notice it's warmer, okay? Scalding is around 150 degrees Fahrenheit, and this is when you start to see some bubbles that collect on the sides or at the bottom of the pan. You'll see them kind of have bubbles around there, but they won't come up to the surface at all. They'll just kind of simmer at the side and stop, and then they'll go away. The next level after scalding is what we consider to be simmering. And this is a pretty large heat difference from 180 to 211, to where now you have these bubbles that are coming up to the top or the surface, but they don't break through. They come up and then they kind of evaporate. All right, so we have lukewarm, scalding, simmering, and then the hottest level that your liquids can get would be the boiling stage. And this is when those large bubbles come up to the top and they actually burst, releasing a vapor in the air. So when you're boiling something, you'll see a whole lot of vapor or steam come off the top of that liquid. The temperature at which things boil is 212 degrees, and that is kind of standard for water at sea level. And it usually, no matter how fast the water is boiling, if you're at sea level, it will stay at 212. The heat can be turned up more higher than that, but the temperature will remain constant, which is kind of pretty cool. The heat of vaporization is what happens when you get that vapor that comes up out of the top of that boiling water when the bubbles are released. And then there are 2 other factors that influence how foods are boiled. One is the atmospheric pressure, and that's the pressure that is being pressed down or exerted down on top of the pan of the water or the liquid. And you technically have to overcome that in order for something to boil. So if you are living in a place where the atmospheric pressure is lower, so like at higher elevations, then the boiling will take place easier than at a higher elevation than it does at sea level. So in other words, the temperature at boiling is lower if you're up on top of a mountain, like in the Rocky Mountains, than it is towards the ocean. And the boiling temperature of water drops about 1 degree Fahrenheit for every 500 feet you gain in elevation. So people who live at an elevation of around 8,000 feet, they can boil maybe around 196 degrees Fahrenheit compared to the 212 degrees Fahrenheit that you would find over in the ocean area. The vapor pressure is the temperature at which you have the vapors coming up from the water. At room temperature, vapor pressure is low, but as the water temperature rises towards boiling, the vapor pressure will exceed atmospheric pressure, and it will help some of the water molecules escape. So in some cases, you'll actually see the steam come up before it boils, depending on how quickly it can move through the atmospheric pressure. Now, frying in lab, we'll talk a little bit about different types of thermometers, but if you're ever frying something, you'll notice that it requires, and some recipes will tell you and some don't, they will tell you how hot to get the oil when you fry it. Typically, it's around 375 degrees. Fat and oil do not boil. You may see little bubbles around the bottom, and you may see the surface of the oil moving, but it's not going to have big bubbles, and it's not going to release a vapor. And so you want to make sure that oils don't get too hot, and we'll talk about this in the fats and oils chapter. But really 375 is kind of the standard for which you're going to get to your deep fat frying. Be very careful if we ever fry in class or if you're frying at home that you don't add too much sugar and you don't add any water, because that will cause the fat to then splatter. Now these thermometers, we'll do some of these thermometers in class. These over here are, some of them can be your deep fat thermometers or your meat thermometers here. This is considered a candy thermometer. Some people will also use it as the deep fry thermometers. And then there are appliance thermometers that you can keep in your refrigerators and your stoves to make sure that the stove is reaching the temperature it says it's supposed to reach, and that your refrigerator and your freezer are at their correct temperatures too, to control bacteria. Now, there are three methods of heat transfer that we need to discuss. Conduction is the first one, and this is when you transfer heat from one molecule to another. So for example, if we put the pan on the stove is going to get hot, it's going to conduct the heat from the stove up to the pan, and then the pan is going to heat up and transfer further into the food. Two major types of materials that pots and pans are made of to help conduct electricity, or excuse me, not electricity, but heat. One of them is aluminum, which is better, but not a lot of people like aluminum because it's not real shiny and pretty. Stainless steel is a little bit more common because of its shininess, but if you have a stainless steel pan, it doesn't conduct heat very well. So a lot of companies will put that copper bottom on it to help transfer and conduct that heat better. As a side note, water is a better conductor than air. So that's the first method. The second method is convection, and this is when there's some sort of movement, air movement or liquid movement occurring that is transferring the heat throughout the system. If you've ever worked in like a commercial kitchen or a restaurant, or if you're a dietetics major, you'll work in the burger cafe where there's a convection oven, and in the back of that oven is a fan that blows the hot air around to try to help transfer the heat uniformly around the cake or whatever you're baking. In your home, you probably have a standard oven. There's no fan, and so you're relying on a lot of conduction to be occurring where it heats from the outside in. Now you can stir things to try to create some more heat when you're stirring in the pan, and that will help. But if you get the air movement and the bubbles that come up, that will also create some convection heat. The third method is radiation. And this is a direct transfer of energy from the energy source to the food. For example, broiling, if you've ever broiled anything in the oven, you're not actually touching the coils, you're not actually moving the air around, but the heat moves from those coils down to the surface of the food and heats it up and cooks it. Microwaves are another kind of example of this. What they do is they create waves called microwaves, which cause the molecules, particularly the fat and the oil in the food, to vibrate very quickly and to create heat and thus cook the foods. But you must have a food, if you're putting it in the microwave, that has water or oil, because it won't cook. And as a side note, you never want to put metal or any sort of styrofoam in a microwave because it will melt.